In this section, we'll talk about operators. Operators are classes which hook into the event loop and respond to various events based on how the operator has been constructed. And the intention of an operator is to operate on the scene or take some type of action. So for example, if we have a way of orbiting with the scene, that's supported by a camera orbit operator that's going to respond to most likely a mouse down event and a down in motion, a mouse down event and a mouse move event. And while the mouse is moving, we'll notice that one of the mice buttons is down, and we'll respond accordingly, looking at the change in position and appropriately modifying the camera to give an orbit result. So they're designed, the interface for the base operator class is designed so that they're GUI and platform independent, with a couple exceptions based on events that might only be supported on certain platforms. So for example, if you're on a Windows desktop and it doesn't have any touch event support, if it doesn't have a touch screen, that's only going to have mouse and key press events. It might have a touch enabled screen, and then there'll be touch events as well. But in general, not any operator can be written, will be written in a GUI and platform independent way. So it's completely agnostic of whether it's MFC or QT or X11 or what have you. We do provide a range of built-in operators for convenience out of box. Here's a list of them. A wide range of camera manipulations, some selection ones. Select operator is just an aperture operator, single point with an aperture around it. Area operator, select area, fairly obvious. Some highlight and some miscellaneous ones. And it's fairly straightforward by looking at the source code to these operators, which is provided to customize, write your own custom operator, which we'll get into in a bit. Like I said earlier, all operators are derived from HPS operator, and they are attached to a view. So the idea of using an operator means we have to have our view with a current operator set. They can be chained as well, but operators, as implied, do require the view hierarchy to be created if you're going to use operators. So that canvas, view, layout, and model hierarchy structure, which again, all the sandboxes have pre-created in them. So we just quickly scroll down through some of the content here. We could see to attach an operator to a view. Okay, in this case, we're going to create a new view. We might do some other initialization. And we're going to create our new orbit operator. We'll get a pointer to a new orbit operator. It's going to respond to the middle mouse button in this case. And then we're going to push that operator onto what we call the operator stack that will make it active. Okay. And this shows how we could have some other modifier keys passed in. For example, maybe you only want the user to be able to orbit if they're also holding the control button down or the shift or something like this. Okay. And you can combine operators. So we could chain them together. We have a flow chart here to show how we would handle the dispatching of different events down through chained operators. So that's something offline you could go ahead and check out. And as mentioned before, we can add operators to a view by calling getting our view's operator control, and again pushing operators onto the operator stack. Another thing that's supported, or we'd like to cover here, is some example of custom operators. Again, the idea is in your implementation of the operator, in your header, you would define what methods this operator is going to implement, support. And down here we have an example of a mouse operator that's going to create a sphere. Okay, the user is going to click on a center point and drag to set the radius of a sphere. So here's our implementation. It's obviously going to need to handle mouse down, up, and move. There's a convenience utility function called construct sphere outline, some compute distance, some temporary segment here for our drawing the sphere outline, sort of the construction sphere geometry, and so on and so forth. And if we go down and look at the different implementations of the methods, we have this is a view attached. It's going to set up some of our temporary geometry segments, get them populated with the right attributes that we care about. And then we implement our mouse down, grab the initial point, doing our mouse move. As you can imagine, with that next current point, we're going to construct our sphere outline. So every time the mouse moves, construct sphere outline will actually flush the current outline from our sphere segment and insert a new outline. If we were to look at the construct sphere outline source code, which is all available to you here, and then mouse up, we're going to flush out everything, and it looks like we set up our various coordinates appropriately, and then we'll actually call the insert sphere method with the appropriate values. And of course, we do another update in the end. So construct sphere outline, based on the information coming in, we're going to draw a marker in the middle of it. We have a radius line and then a circle. So that's giving us kind of apparently a 2D profile view of this constructed sphere. Okay. We could have imagined that this could be modified to draw a temporary 3D, actual temporary hoops 3D sphere that had faces off and edges on to show a full wireframe 3D sphere, instead of, in this case, just a 2D profile sphere. So get an idea of how you could customize operators. And the exercise we would get into here is very, very basic, where we would create a simple marker operator where anywhere we click, we would want to insert a simple piece of marker geometry underneath the current mouse position.